How about now? Can you guys hear me okay?
Yes.
I'll try not to yell so much. I can still yell. My name's Andreas Christensen. I'm a teammate here at Source Allies. I've been with Source for about 7 years, and I am enthusiastic about doing small projects with my son. So we have learned a lot about Bluetooth Low Energy in working on this car/tank. It's no longer a tank. It was once a tank, but it got a new chassis. And I'd like to share some of the things we learned. There's a lot of complexity about Bluetooth that we can dig into the details so that you get to see how all the pieces work. And in the end, we'll provide a couple libraries that will make it way easier so you don't have to go through all the little things and get everything right. Okay. Who here has heard of Bluetooth in the past as a technology? Who here has a Bluetooth device on them right now? Probably everyone with a cell phone. How about like a little medical device, a ring, a smartwatch? If you have like a blood sugar monitor, or if you have something for athletics, like if you have a heart rate monitor that goes strapped across your chest for when you're running or lifting, those are probably using Bluetooth Low Energy. The difference between traditional Bluetooth and low energy Bluetooth is traditional Bluetooth was like a full duplex stream between the two sides. And you could send a file, you could stream media, you can send whatever bytes you want, and you sort of build the protocol on top of that. While Bluetooth Low Energy has attributes, and it uses the generic attribute protocol, and it's more confined. I have a QR code here with links to the repos, as well as links to the IDEs that I'm using, as well as links to like some learning materials if you'd like them. So hopefully that is scannable. I'm not sure if it is between the projector and all that, but you can follow along if you want to. You can download the repos, you can download the IDEs, and you could do most of this project with me as I walk through the code. So while you're considering doing that, or doing that if you want to download a bunch of stuff, let me talk about the Crimson disk. This is the Crimson disk. It was found originally in the 1840s. It was found in a small Prussian town underneath a church. There were two 12-year-olds who found a crypt, crawled into it, and found a Viking horde because 1,000 years earlier, not 1,000 years, 800 years earlier, in the 10th century, there were Vikings across the river who buried their dead here. And the church was built upon the graveyard, which was built on the previous Viking graveyard. So they found a crypt, crawled in, found this loot, and the church said, you know, that's on church grounds, let the dead be dead. We're not taking the Viking loot. Fast forward 100 years to the 1940s. During World War II, Polish officers arrived, 2 officers who were brothers, showed up in town, and somehow they learned of this Viking horde, and they were willing to take it out. And so they went into this crypt and took what was there, which was a few coins and bracelets, all of gold. And that's where they found this Crimson disk, but they thought that it was nothing. They thought it was copper or brass, and they put it in a box full of buttons. And another 70 years later, in 2014, their one of the soldiers' great-granddaughter found this box of buttons, found this gold coin in it, took it to her history teacher, who took it to the university, who did some research and eventually published about this 10th century disk. And you can see on here, Harold Crimson, who was the Viking lord of the time, also known as Lord Bluetooth. And that's where Bluetooth gets its name. Historians think that Lord Bluetooth actually had a discolored tooth. That's how he got the nickname. This is in a time before dental care, so he probably had a very painful rotten tooth, and it was probably really stinky. So when you hear Bluetooth, think stinky breath. This is my agenda that we're going to go through today. I have not very many slides about terminology and how this works. We'll do 6 or 7 slides, maybe 10 minutes of what is Bluetooth Low Energy, what's it built on, some terminology like what does it use to get things done. And then we're just going to go right into code. We have 2 code bits. We're going to show you how to like take an Arduino device, plug it into your computer, and then flash it with some software that you wrote. So the sketch is in that QR code from before, and putting the sketch onto an Android device, we're going to show you how to do that. Arduino device. Second, we'll go through the Android side, show you how to get your Android phone into developer mode, how to connect it to a computer, mirror it in Android Studio, and load apps onto it so you can try them out, write your own code. So if you haven't done that stuff before, it's probably stuff that you have in your house. If you've got an old Nano kit from when you were teaching a kid, or if you have an Android phone, you might have all the technology you need. It's just a matter of plugging it in and seeing what you can build. We'll go through some gotchas, and then if we're really lucky, we have a quote from my son. Okay. Any questions before I start? I have a lot of talking to do, and I want you guys to get your questions out. So if there's something that I go over that doesn't make any sense, or if I stutter, or if I have a stroke up here and I'm like falling down, just stop me. Stop me and ask what's going on. I'd be glad to answer any questions. I want to make sure that you guys get what you need out of this, so let me know what you need. So Bluetooth Low Energy is built on generic attribute protocol, which is built on profile. Those are technologies that just declare the client-server topology and what they contain. Here is the first thing that you have to like wrap your head around that isn't what you would expect. You have clients, also called centrals, and servers called peripherals. So the client is not the peripheral, the server is not the central. So you have to get that terminology backwards. The peripheral is the thing that has a sensor, like a knob or a dial. It has some data. And the client, the central, has to connect to that peripheral and get the data. So you can wire this either way, and you can have it go the other way, and the central has the data. But in general, the peripheral, like your ring or your watch, will connect to your phone, the central. So it's already a little bit backwards from what you're thinking. I'm sorry, I already messed it up. Your central, the phone, will connect to the peripheral, like your watch or your ring. So if you're thinking about like your phone is the server and it connects to the Bluetooth thing that has some data, it's the opposite. Your phone is the central that will connect to the peripheral, but the peripheral runs the Bluetooth server and exposes the services and advertises them and says, I have these services. The services contain these characteristics. The characteristics contain these descriptors. And characteristics and descriptors are both attributes. Attributes have UUIDs, their values, and their permissions. Whether you can read from them, whether you can write to them, those are the types of permissions. You can also have permissions, can I get notified of changes? Can I get indicated of changes? A notification in Bluetooth Low Energy is, I want to know when it changes, and I'll let you know when I got the message. An indicator is, I want to know when it changes, and just forget about it. I'll go get the change when I want it. So it's whether you communicate the other end of that transaction. Okay, so central is a client, server is a peripheral. They contain services, they contain characteristics and descriptors. All of those are attributes. You only have the UUID, the value, and the permissions. So between the UUID and the values, you have to like say what this thing is. And the way that's done is by well-known numbers. There's a number of UUIDs, both short and long. That's the next bit of Bluetooth Low Energy that are well-known. They're published in a list of well-known numbers. And if you use those UUIDs, you're saying you're a type of thing. So tank controller might be a well-known UUID for a service. And within a characteristic on that tank controller, you would have a well-known UUID that is the name of the characteristic. And so that gets sort of enveloped into the characteristic. So you can't say what the name of the characteristic is because you only have the UUID and the value. But the characteristic can have a descriptor, which has a well-known, this is the name descriptor, and that has the value of the name of the characteristic. So a little bit a roundabout way of naming these things. They don't have a lot of attributes, they just have a UUID and a value. Any questions about how some of that works?
Is the client-server flipped the way you normally would think of things like this because like, peripherals are sort of smaller devices that don't really have a way to interface with the other thing?
The peripheral, the smaller device, will still run the GAT server, the generic attribute profile server, and that GAT server will advertise the services that it has, and those services will have characteristics and descriptors that are in that advertisement. Sure. Yeah, so Bluetooth, full Bluetooth, not low energy, is like full duplex communication where there's an open channel and you could put whatever bytes you want through that channel. You could build your own like telnet type of thing on top of it. You could sort of pipe that into SSH and like connect to a computer that way. You can throw big chunks of a file through there and let streaming media flow through. You have like a full communication that's always open and you can put stuff through whenever you want. Bluetooth Low Energy is individual bits. I know that you have this service, I know it has that characteristic, and I just want to get the value. So it's much smaller.
Love that, thank you.
So is there compression then going on?
That is a good question. I think yes, but I do not know.
It sounds more like it would be a type of encryption.
There,
The server already knows what to expect, and instead of two-way communication, you have one-way communication from the Bluetooth.
On the low energy or
The low energy to the server.
each individual request and the notifications and subscriptions are one request through and then a follow-up request back, but they're all like one send and forget, and then you build the acceptance on top of that. So.
This slide is basically saying that you're making a hash to send over to the server so that the server understands what the output from the Bluetooth is.
Let's say, for example, that you have a characteristic that you want to subscribe to, the position of this thing, so you know whether to go forward or back. You would subscribe via descriptor. There's a well-known descriptor for I want to subscribe. And you can do the notification well-known one or the indicator well-known one. And once you have subscribed, it's up to the peripheral that has your subscription to notify you every time it changes. And you could choose to debounce that. You can choose to not notify them sometimes. You could write code that only notifies them only on odd days. It doesn't really matter, but you write the code and then you send individual notifications. Hey, this value has changed. If it's a notification, here's the value. If it's an indicator, just it's changed, come get it when you want it.
The compression is going to be lossy, but if you use a hash encryption, then it will be less lossy, I think.
The permissions, I'm not going to really get into security here, but the way security works is you would write to a specific descriptor a code, like a 4-digit thing that's displayed on your peripheral, and you'd write that into the descriptor, and then from there, the peripheral will know that, oh, this particular central is okay, good to go. I will let him get notifications, I will let him subscribe, I will let them do all the things that they're allowed to do. But it's based on first writing into some descriptor, and they have the device ID from the connection. I bet there is encryption. I bet there is compression. I don't know about it. I'm sure there's a lot more to learn. So I don't want to lead you to astray that there is or isn't. Next slide, if you guys are ready. I don't want to stymie any conversation. This is the process of getting data once. The peripheral has to advertise services and the central has to connect. So if you're a central, you could also be a peripheral, and you could have both sides running at once on your Bluetooth server, on your phone, for example. Your phone does that all the time. But if you want to connect to, if you're a client, the central, you have to connect to the peripheral. So it can't go the other way. You can't have your smartwatch, if it's a peripheral, connect to your phone. The phone has to connect to the watch. And then you request a list of services. You discover what services and attributes and characteristics are there. I'm using attributes generically. It is characteristics and descriptors. Once you have that list, you can say, hey, that's the one I care about. Give me the value. And you have gotten the value once. You connected, you got a list, found the thing you wanted, and you requested it back. You can also subscribe. So you can write to the descriptor saying that you want attribute value changes, and then you can get an indication or notification back from that device. And you can read that value if you got an indication. If it's a notification, you'll get the value as part of the notification. This is how things work, like if you're wearing a smartwatch and your phone thinks you've fallen over and it wants to dial the police for you, it noticed that there was a sudden accelerometer shift on your watch and then no motion for a second. You might have just jumped onto a bed, but your watch isn't quite sure, and it's going to send the notification that this person might have fallen down. This is my fall down indicator, and your phone's taking action. So if you have like an Apple smartwatch and an Apple phone, I know that's something you can set up. Any questions about getting values and subscribing?
So you get a list every time?
When you, I'm going to stop my slide and share another screen, and I'll show you a list that you can get. So as a demonstration, these are the Bluetooth low energy. Oh, this is impossible to see, isn't it? And I'm not sure I can zoom in. This is a light blue. It's a macOS app. I'm going to turn on the controller here. Oh, I should put it under the camera. That would be smart. I don't know if you can see that, but it is currently advertising. It's the peripheral. I'll refresh these, and since it's so close, I'm hoping to see it right away. Or not. The answer to your question is yes, you can get a list of all the stuff that's out there.
Every time you initiate.
If you know exactly what the service is and you know what the attribute you want is, no, you don't need to get the list. You can just say, here's the UUID of the service. I'm going to connect to this device. I'm pretty sure you have this service. I'm pretty sure you've got this attribute. Give it to me. And if it doesn't have that service or that attribute, you'll get an error back. But yeah, there are various scanner type things for Bluetooth Low Energy that you can download. You can get one for your Android phone, for your iOS phone, for your macOS, for Windows. But I'm seeing, I would categorize it as a little less than 100 in the room right now. So there's all sorts of Bluetooth stuff going on. And I'm probably picking up stuff on the floors above me and behind me in the service room and who knows where. My next slide is to talk about Arduino. So we're going to look at the code. We'll make sure the sketch compiles, connect the hardware, load the sketch, and then connect to the serial port on the Arduino so you can see like what's going on. Everyone ready for that? I sort of rigged this together so that you could follow along if you had the right software and devices, but do not feel like you have to. Here is the sketch that we have. That's not big enough, is it? Let me know when this is visible. Is that large enough? Okay. So we have some motors. This is the sketch for the tank. We also have to do pulse width modulation for the channels to turn on and off the motors in a way that makes sense. And there's a driver in there that does that. I wouldn't worry too much about that. There's also an OLED here in the front that currently is connected to the controller. I'll turn it off, and it'll show that it's waiting for connections. I'm just going to turn the controller off if I can. There we go. And so you should see that it's waiting for connect controller. The important bits are that we will scan for a certain UUID on Bluetooth Low Energy. I randomed this UUID. It's not anything important. If you know exactly the type of device you have, you can look through the well-known numbers for a UUID that exactly matches that type of service. So if you're building a monitor for a smart home, there's probably some big manufacturer who has built 30 different kinds of that monitor, and they will have a spec with a well-known UUID and the attributes that you should present if you use that UUID. So you can look through those well-known numbers and find something that matches if you're building something that you think a lot of people have built before. I'm sure people have built little toy cars, but I didn't want to go through the effort of figuring out the correct way to do it, so I made a random one. And you can too. I'm going to go down to the bottom of the loop. This while loop is looking for an available peripheral which has that UUID. It's going to print out what services are advertised, what the local name is, and then it will accept control. That's the method that we sort of skipped above. And once it loses control, it'll start scanning again. So it's just taking from this state machine, from this state of scanning to accept control and have another loop where it's reading the value and subscribed to the attributes. And then when you're done, you start scanning again. And if you can't find anything, that's the connect controller text. which you might be able to see on this itty bitty screen on the tank. Okay. Any questions about that before we go into the accept control? Who's excited to accept control from a controller? This is really good. This is going to be so much fun. I've commented out the extra types of peripheral characteristics. This controller, I'm publishing not just up and down on left and right, but also side to side, and you can click down. So I'm publishing all of that. And so I've commented out the stuff that we don't really care about right now, because those aren't important for making the tank move. If you had a horn, or if you wanted to like drive a little camera on top, maybe you'd want some more characteristics. You'd care about that stuff.
Where do you get those characteristic keys?
These I made up myself. So these are made up. Again, there are well-known characteristics and descriptors. So if you knew that this was like an Xbox controller and it was going to have up, down, left, right, you could use a well-known characteristic. I was lazy. I'm going to go up to the top of this accept control. As we're connecting, we want to actually allow the peripheral to connect. And then we're going to discover all the attributes. That attribute discovery is buggy on the Bluetooth Low Energy Arduino library, which is why I have some fixes and I had to run this locally. Importantly, the Arduino Bluetooth Low Energy library doesn't respond well to full-size UUIDs for descriptors. That is 16 octets versus 2 octets. Oh, you cannot read that at all. Sorry. You should have yelled at me. Aren't you guys good at yelling? You must yell at me. Tell me! Yeah. This little bit in here, previously this was hard-coded to 2, which is if the response buffer in position 1 is either 1 or 0, and they were just assuming that it would always be a 16-bit UUID as opposed to 128-bit. That is 2 octets versus 16 octets. So I just added a little ternary here, and it fixed a bunch of stuff. So it's an open source library. I probably should commit this stuff. But there are some changes there. As it starts up, you're going to see a whole bunch of debugging output that if you want to dig into, you can, but I had to figure out what the heck was wrong. OK. So discover attributes. That's all going to happen in the discover attribute. It's to print out a bunch of debugging stuff, eventually find all the attributes. For each attribute, I'll find all the descriptors. Some descriptors are well known, like here's the name of the attribute, or here is what you need to write to if you want to subscribe. Some descriptors are just random stuff that you can put in. You can put whatever descriptors you want. But if it uses a well-known name, you probably should use it. And the Android side will have some examples of well-known descriptors. We are going to see how many characteristics and do other printing stuff as I was trying to get this work. Wouldn't worry about that. And finally, we're ready to subscribe to the 2 attributes we care about. I'm sorry, they're characteristics, which all characteristics are attributes. So I wasn't wrong, but it's misleading. They're characteristics. The 2 I care about are A096 and B5EC. That almost says like bacon or something. I'm not quite sure. OK, so we're going to subscribe to those 2 things. If I didn't actually make a characteristic, well, something's wrong. We should probably stop. I have some default values. And then I'm going to check whether the values have updated. So has the value of this characteristic updated? This is in a busy loop. So I'm while looping here as long as that peripheral is connected. And while it's connected, if the value updated, then I should read the new value, print it, and probably set it to something. Print read value. Oh, yes, I'm reading it into ly. So this variable up here, it's going to get the new value. This is modifying a parameter. As you do in C all the time, right? I'm a Java programmer, so this is not intuitive to me. I think in C# you can do like out parameters, which is really cool. You can declare that you're going to be mutating these parameters, and you better read the memory location back when you're done. OK, so I do the same thing for ry. So we have a left and a right, up, down. Those are our ry and ly. And then we have to do some math to turn it into plus or minus 255. We're going to get 0 to 4096. And we have to decide, should we turn the motors on? And if so, how much? Stuff in the middle, we just do nothing with. So if you happen to be, I should go through this in sequence. If you're divided by 3, then you're at the low side between like 0 and 1/3 of 4096, and you should be going like backwards. We'll print something to display, print something to the display, as well as I think we might write something to serial so we can see it. If you're between 1/3 and 2/3, you're in that middle section, I think we just do nothing. I think we write the duty of not enabling it at all. Enable pin 1 duty, somewhere in here we're turning it off. And if you're on the plus side, greater than, so this is the above 2/3. So we're setting the duty cycle to some approximation. We're just doing a linear, multiply it by a big number to get it between -256 and 256. And then otherwise, we just set the enable pin to 0. Turn off the motor if you're somewhere in the middle. You're not all the way up and you're not all the way down. This is a super dumb way to do this. It does work, but there's probably lots of smarter ways. You'll notice that the controls are not very responsive because until you get to the upper 2/3, you're not even turning anything on. But it works well enough to drive a toy tank. Probably not good enough for, a blood pressure monitor, but. We do the exact same thing for LY. I won't really walk through that. And then when we're done, we just update the display with where we're at. Are you guys ready to see that happen? Yes. Okay. Woo! This is the good stuff. I've already turned on the serial monitor. Let's see. I'm going to turn this on. It's now discovering actors. I just turned on. Oh, that's so tiny. I'm not sure you'll be able to see it. Would you be able to switch the monitor to the camera? I don't know if you can switch it, but it's connected. I can see it connected here, and we can see that we got a bunch of descriptors here. And now as I move up and down, you can see the value updating. And is this? Yeah. It's not quite real time, but it's darn responsive. It's really fast. So this is how the piloting works. And I can get the notifications of the value being updated from here, the peripheral, to the central. Does that make sense? So the peripheral has the server.
But they're not on your end.
Yeah, trying to get the screen larger.
That's okay. Yeah, so just run through that whole thing again. The server. Woo! So it might be too close to see much, but you can sort of see that the numbers are changing as I go up and down. No, I'm not sure that's super useful, but they go to 0 on the y-axis. I can also change the x-axis, and I can punch down, but those are not being transmitted because I'm not subscribed to those attributes. I turned it off for the simplicity of the demo. But up and down work, and you can see that up and down. Now that you've done all that work, could you switch me back to, yeah, you can see the up and down in the serial monitor of what we're outputting, and those outputs are just from up here as we got new stuff. So we're just printing it out. Value updated for one of the two. Okay, one more time. This has the server, it's the peripheral. Central connects to it, says, do you have the attributes I care about? Oh, you do? Let me subscribe to that. As the attributes changes, notification goes back to the central, back to the central, yes, that's connected. And the central can do whatever actions it wants, like run a motor. Okay, this is how probably a lot of your newer, I don't know, like an RC cars or if you have a quadcopter, it could easily be using this. The range on this is pretty limited, so I'm not sure you'd want to use it for a quadcopter because it gets out of range. That thing has to land. But this is an easy way to build a cheapo toy and to have somebody pilot it around. It's not quite radio controlled, but it's good enough for 20 or 30 feet. I want to do this with my cell phone, though. And that's the next part of the demo. Do I have a time indicator? 6:30. Oh, yeah, I'm good. We're going to spend 10 or 15 minutes going through the Android side of, I really don't want to carry around a 3D printed little box with some PS4 sticks that I mounted. I'd rather just use my phone. So let's make that happen. Okay, we already know this is working. It's listening, subscribing. If I could get light blue working, you'd be able to see the Arduino device, and you could see all the services that it's offering, but that's not too important. We're going to move ahead to the Android side. There is a lot of code. I specifically chose not to use Android libraries for Bluetooth Low Energy so that you can see all the details of like, I have to advertise, and I have to deal with people subscribing, and I have to check permissions. And Android gives you no niceties out of the box if you don't use a library. So there's a bunch of code, but I'm going to go so fast that you won't be able to understand anything. It'll be OK. And then we'll get it compiling. I'll show you how to get your Android device in developer mode. Who knows about like clicking a thing 10 times? Who has done that before on an Android device? I got 1, 2. If you have an Android, who has an Android device right now and hasn't done that before? This will be super fun, so fun. We'll do that, connect the device to the computer, and then we'll run the activity that is the app, the Android app, and we'll actually open a Bluetooth server. Hopefully, the tank will connect. If not, it's a dud. We'll see. OK.
How many people can connect to the tank?
So the server is in the controller, and the tank connects to the controller. That client server central peripheral thing, it messes me up every time. I didn't want to curse there. I almost said screws me up. But it screws me up every time. And when you say how many people can connect to the tank, nobody can, because the tank connects to the controller. But if you had a controller, it would connect to yours right away. I've got nothing to limit it to. If you know my UUID, if you could guess my UUID. I showed you. Yeah, it's committed. You can see it in the GitHub. You could totally make your own. And next time I do this talk, start driving around. That'd be great. I would enjoy that a lot. OK.
Why you can make your own IDs?
No, because there's no security in it, really. If you connect to, so you can see a list of devices that are within range that have enough power that your Bluetooth low energy, whatever system in your computer or on your phone can see it. You can see the device, and you can ask for a list of all the attributes, and you can ask for a list of all the descriptors for each attribute. You can iterate through that and get all those UUIDs. So there's zero security in the UUID. I really just chose that because I was lazy. Sorry. Were there other questions there? If you want to do security stuff where like, I want to make sure that only the right people connect to this, what I would do is on this device, show some sort of code, and then have to punch that code into here, and I'd have the server connect to the, I'm sorry, not the server, the central connect to the peripheral, and in some magic descriptor that I've written, put the code that I ask for. And if you don't get exactly that code, then that device is not allowed to subscribe. And that's how you could lock it down so that if I was in a coffee shop working on this presentation just last weekend, and there were like hundreds of devices around me, and I just started scanning them to make sure I knew what I was talking about. But you can connect to each of your cell phones if your Bluetooth is enabled. I can see what services you have and what attributes they have. Probably nothing I care about, but you could look around. Generally, the permissions are set up so that you can't actually see the values of the attributes, but you can see all the attribute IDs, all the descriptor IDs. More security questions? I know this is DevOps, so we better do a lot of security. OK. I'm going to start with, yes. Yes, I can. I think I can. Oh, lordy, lordy. This is based on IntelliJ, so I can zoom somehow in here, right? Shift, like that, equals, oh, it's equal, OK. How's that? Is that visible?
Yep.
This Android.Bluetooth has all the stuff you need in order to build it yourself. If you don't want to use a library, this is probably what you're going to use instead. I'm not blocking this, am I? OK. I have here a few UIDs that I'm going to be using. This is the exact same service UID that I copied over. So when the tank tries to connect, it can actually find the service it cares about. There is a well-known sort of format for a long UID to translate from a short. So this is the short UIDs for the two things that, the two attributes, sorry, characteristics on the service. I mentioned this one sort of looks like bacon, maybe not. But I need to jam those into these 4 X's. So I'm just going to replace them here to get a much longer UID. So all the short UUIDs, they might only come over as 2 octets, but they actually can be translated, and the software should treat this much longer UUID as the short one if it is exactly this for the rest of the UUID. This is in the spec, and it's well-defined. So in terms of well-defined magic numbers, here's a bunch more. I also should talk about CCD IDs. This is the first magic, the magic descriptor. This is what you need to subscribe to. I don't remember what CCCD stands for, but it is 2902. And then you can get the long one if you put on here. The Android libraries only take long UUIDs for Bluetooth Low Energy. The Arduino ones like short ones much better. In fact, there's a bunch of bugs if you use long UUIDs. So that's why we had to hack the library a little bit. But these are just a couple of examples of stuff you can find in the docs. Texas Instruments has a bunch of documentation and learning materials that are very useful for this. Okay. There was a ton of stuff that we're going to have to do in order to get through the permissions for turning on Bluetooth on your Android phone. It's 6:39, so I'm going to go fast and not really tell you too much about it other than different versions of Android have different permissions. Based on the version of Android, you might have to turn on your Bluetooth in different ways. And it may not work if you have an older version. So I'm requiring Tiramisu, which is a newish version of Android that my phone happens to have. I trust this would work with most modern phones, but if you have an old Android device, no guarantees. I have some lazy Kotlin things loading here, just getting from the Bluetooth manager, the adapter, and the advertiser. On creating, this is just setting the theme. We have sort of a very simple app that we'll be able to look at in a second, and I'm using the material theme. Probably don't care about that. In order to turn this on, you're going to have to request Bluetooth permissions. You will need to turn on your location. I'm not sure if that's right in here somewhere. Bluetooth, because when you turn on a Bluetooth server, you can see nearby Bluetooth devices. Android treats that as needing the location permission as well as the Bluetooth permissions, because you can track down where you are based on what devices are nearby. The same way that iPhones track AirPods, for example. You can figure out where you're at by what's nearby. You need to request lots of permissions, including lots of Bluetooth permissions. Eventually, you hopefully can get this turned on. I think there was something here about location, or maybe I skipped through that. But that first 100 lines or so is just, give me the permission so my app can use Bluetooth. It's not super simple. And now we're ready to actually fire up the service. I mentioned that this thing is a peripheral. I'm going to kill this one so I don't connect to the wrong one eventually when this does start working. Okay. So this, when it's running, is a peripheral that is going to advertise a service. I'm also going to advertise the same service on my phone. And so I need to start up this GATT, G-A-T-T, generic attribute profile service. I'm going to use the service UUID, and I'm going to advertise 2 characteristics, one for the left track, one for the right track. And you can see that I have to assign a bunch of properties. I mentioned that every attribute has UUIDs, values, and permissions. The permissions on the characteristics, I want like read, write, and notify. And then I also need a way for you to subscribe. And that was that magic CCCD UUID. And I'm going to give everybody the permission to read and write to that. That way you can subscribe and unsubscribe. So this is what I want to advertise as my service. And at the end of this, I'm going to start status, advertise, somewhere in here, advertise. Advertise data, set device name, set the service UUID, build it, and then start advertising. So this start the server and then start advertising is the magic to, like, you've got the permissions to turn on Bluetooth, you've built a service that's just in memory, that service has attributes, you've got the right descriptor, now we need to advertise that that service is ready to be connected to, so that hopefully your tank can connect and do stuff. I've got some functions to stop advertising. There'll be some buttons on the main screen that you can see. And then this is more stuff for just building the service and putting the right track and the left track in the right place on the server. I do have this mutable set of Bluetooth devices that are subscribed. So if there were 6 tanks and they're all subscribed to left and right track, there'd be 6 things in these mutable sets. So that's where I'm going to like store off that I've got a tank connected and it wants to know when this changes, so this is who you should talk to. And then finally, we can start the server. Okay, so server is hopefully started. I've got some code here to stop it when I'm done. We have a whole bunch of callbacks to think about. So Bluetooth GAT server callback, one for on connection state changed. Have you connected or disconnected? I don't do much but just log it, but I will yank any subscribers that are in the list. So if one of the tanks, assuming there are 6 of them, disconnects, then I also want to remove those subscriptions, so I'm not trying to send it stuff. They can send me notifications, and I'm not sure I care, so I'm just logging them. Characteristic read request. So this is saying, I want to know the value of a characteristic, and I'm going to have that value for either left or right tracks, and I'm going to have to convert it to a byte array, and I can send that response. The actual value is this left power, and I've got another one for right power. So these are just variables that are in my sketch, in my app. And I'll keep track of those based on what buttons you press, whether it's on or off or 50% or whatever. And this is for reading one time, but I really need this tank to be able to get notifications. So that is a characteristic write request. That's the descriptor write request to subscribe down here. So the descriptor, I need to know whether you're going to go for the left or the right UUID, and then I also need to know, the descriptor is the CCCD ID, and then the UUID for which track you want to be subscribed to, and then I just add you to that mutable set. So hopefully that makes sense that the tank is going to connect to the server. This peripheral is the server, and it's going to say, I see you have a descriptor on this attribute I care about. I'm going to put a 1. I want to write a 1 to there. When you see this request, that means I'm subscribed, and you should send me notifications. And this is how I'm handling that, by hand, very manually. You can also read, am I really subscribed? Did that really happen? And that's reading from the descriptor, and you'd handle that in the on descriptor read request, and you'd have to do some logic for like, is it the left track, or is it the right track? Are you trying to get the descriptor UUID or some other UUID? So this when statement is just taking a tuple, taking a pair, and checking whether it's one of the ones I care about. And if you try to read or write something that I don't care about here, I'm pretty much just going to send GAT failure. I'm going to send, hey, I don't know what you're talking about. Go somewhere else. So we have these magic like left and right buckets of people who should know when those changes, when they change. These are just functions for the buttons. I'm going to have a connect button. Yeah.
Sorry, what kind of polling time are you looking at for the energy efficiency? Do you know?
So there's no polling. It's event-driven. Yeah. So if I have this controller turned on, and I'm not pressing these at all, I'm not moving the controller, the value isn't changing, and I'm not notifying the server that the value has changed, and there's no communication whatsoever, which is why your little tiny ring with a battery that's like itty-bitty can last for days. Because when nothing's changing, when you're sleeping, when you put it on the desk, there's no communication. Does that make sense?
Yes.
That's the huge advantage of this over like Bluetooth. I'm going to call it high energy traditional Bluetooth, is that when nothing's happening, there's no communication whatsoever. The channel's not open.
Is it the same chip? Like BLE?
No. There are tons of devices that were made before BLE was mainstream, and they have a Bluetooth chip, but they don't have Bluetooth low energy. You need updated hardware. There are also new devices, like I mentioned, like a smart ring type of thing. That doesn't have any traditional Bluetooth. It only has low energy. So the ESP32 that's in here has both. Your phone has both. I think this is an ESP32 also. This has both. For most like sort of hobbyist electronics for building stuff, you can probably get both. I mean, these ESP32s are like $4 each, and they're more powerful than supercomputers from the 60s or something. But yeah, if you have a smart device on your person, it might just have Bluetooth low energy. Or maybe it's an older one and it only has traditional Bluetooth. Thank you for stopping me. I appreciate the question. Any other questions? Okay. Am I running out of time? Is that what they're talking about? I got to go even faster. I think I'm talking fast, but I'm not talking fast enough, am I? Left power and right power, this is just setting the power. So when you set the power, I also want to note that the characteristic has changed, and this will do the Bluetooth notification stuff that, hey, you've got a change here. Since it's a notification, not an indication, you actually get the change over the air to the server. And then the set tracks is what's actually called on the front end, which sets the left power and right power, and through the magic of Kotlin, these setters get called. Okay, I'm not sure I remember what this does. I think this is just debugging stuff. Oh, this is for sending indicators, which I no longer do. I think it's just notifications. Or maybe I switched this to be notifications. Doesn't matter. The last thing is that you don't get any niceties from the Android libraries. So if you want to turn, I don't know, an int into a byte array, good luck. You got to figure that out yourself. This is a really cruddy way to do it, but it works. And this is what our front end is going to look like. It's just like 6 or 7 buttons on a page, a couple for like connecting and disconnecting, a text field for what the status is, and left, right, forward, backward, stop. Okay. Who has an Android phone that they want to unlock the super secret dev mode on? You guys want to do that? It's not dangerous, I don't think. It might be.
All the funnest things are described like that.
This is my personal phone. I think that's a text message from Chip. He's in back. Can you guys see enough of what I'm doing here? I'm not sure I can zoom in here. Oh, I can. Whoa. Technology. Okay. So I'm going to go into my settings. And oh, look, my Bluetooth is off. That would have been bad. You can't see it. It's too zoomed in. There. One more. Well, I'm going to leave it at this view so you can see the whole phone. I would like you to go into these settings of like all your phone settings. Head all the way down to System. And then if you look in here, I have developer options, and you probably don't. I think you want to go to System, not Update. There's a System About Phone, and then click down here on maybe Software Information. You might have a version-y thing. I want to say it's kernel version we click on a bunch. Is it the build number? Oh, man, thank you. You're saving my butt. Build number at the very bottom. And I got a little notification here. So I see one person following along. Are you able to see this build number? Click it like it's money. Just click it a whole bunch. Oh, you're missing out.
Well, mine is already has developer options.
Oh, geez. You just turned it on? You just click it a whole bunch. So I blew my mom's mind when I showed her that. But yeah, you click it a bunch, and you'll get into developer mode, and you'll see a new thing right here, which is developer options. And from here, you can get into debugging. Wireless debugging over Wi-Fi, oh gosh, that's hard to see, is the easy way to do this, but I don't have Wi-Fi on my phone for this office, so I'm doing USB debugging. I'm plugged in. And yeah, you can turn that on, wireless debugging. And at that point, it's easy to go into your list of devices here in Android Studio, and I can see my Asus phone right there, Android 14. I think I could probably turn this off and back on to like demonstrate connecting, but you should see it here if you're connected via USB, and you can just double click and see the phone. So you can control your phone. If I was to click and exit out of here, my phone is like moving. I'm not sure if you can see that on the camera, but it's doing its own thing. It's gonna follow, yeah, it's gonna follow whatever I do here on the screen. And then I want to compile and run this app. This is the good stuff that we're hoping to get to. There's a Gradle build running. You guys are still excited, right? Haven't lost anyone? Okay. I trust this build will be successful eventually. It's taking a little longer than expected. I know. That's what we're building, not an Android app, anticipation. I think it finished, okay. And then you can just run your app here. So once you're connected and doing that sort of wireless debugging, it's like pretty slick. If you use Android Studio with default settings, you'll open logcat and you'll be able to see like all the stuff that's happening. This is gonna be very hard on this Zoom, but as I turn things on, this is where you can see the logs. So you can put whatever you want in the logs, and system out is going to get transferred over USB or Wi-Fi or whatever you're doing, and will show up here in Android Studio so you can see whether it's working or what. So I'm gonna hit connect, and this is gonna start the Bluetooth low energy server on my phone, and my phone gets to become this 3D printed controller. So exciting. Let's get down to the bottom. Yeah, things are connecting. Added right subscriber, added left subscriber. That sounds like we might be good to go. Oh, man. I think if I disconnect that, other things will disconnect. And then let's see if we can change the values on one of these. I want to go forward. Oh, hold on. We have stuff. Oh. That may not have been good. Yeah, but okay. Ta-da, it's a tank, it's durable. Yeah, I'm sure my son won't be mad at me forever.
I'm sorry, bud.
Yeah, sorry. Too bad, no more tank. I think, no, some of this is no longer working. Let me see if I can reconnect. But yeah, you can get the communication working and, oh geez. I can run the wheels, I can turn left and right. I don't actually have enough functionality on this to like go certain amount of speed on the left track versus the right track, but I could. If I was a better Android developer, I could have little knobs and dials and I could use 2-finger swipes to do interesting things. As is, it's forward, backwards, left, right, and stop. But they all work, and you can see the communication going through. You can see the new values being set. You can see which UIDs you're writing to. This is the bacon one. So this is a primer of all of the little bits and pieces that go into Bluetooth Low Energy. Yes?
Have you ever played with doing it through web browser, through controlling the controller through?
No. I assume that's possible. Can you get a Bluetooth server running from a browser? Because it needs access to hardware for the Bluetooth. Maybe you can. Oh. Have not tried. That would be cool, though. So we got through the Android stuff. Took longer than expected. Sorry if I keep you late. I've got 4 minutes. Some gotchas. I think I went through most of these as we were talking. There's just a lot to be asked. There's a lot of things that could be better. That could be better in the Android library. Specifically, just don't use the raw Android library. If you wanted to go to Nordic Semiconducting, they have like an open source Bluetooth Android library that's actually good. You don't have to like make these these sort of arcane descriptors that are well-known numbers. It'll just work out of the box, and you can give it names and you can use like a nice fluent API for reading and writing values and getting notifications. No, it's an Android library. It's Kotlin Android. The Bluetooth Low Energy library that's from Arduino is pretty good. I found one bug in it, but I used it for other stuff, and I'd say it's very fast, and it loads. If you wanted to use like a Nano or a different Arduino device, it might have a lot. These ESP32s have a lot of memory that you can load both data and instructions into, while like another device like an Uno, for example, doesn't have nearly as much space, and you want a library that's very slimmed down, and the stock Arduino Bluetooth Low Energy library is tiny, which is great. So I would recommend Arduino on the Arduino library on Arduino, but do not use the built-in Android library for Android. Instead, use something that builds on top of it and does all the little nitty-gritty stuff for you. I just wanted to show you the nitty-gritty so you get an idea of the GATT protocol. My son was very impressed when this thing moved the first time. He gave a very loud vroom. So that's my quote. Joe, age 10, vroom. Sorry this took so long. I'm happy you guys stayed for it. What can I do to help? Any questions that you have? Anything I missed? Yes, John. There is like a full H driver here, and there's 4 motors. I think the wheels were mostly free. A couple of these 18650 batteries, an ESP32, and maybe some wires. I would guess that you could buy all of these on AliExpress for $10. This whole kit, $10. That would be my guess. I think it's less than $1 for the driver, less than $1 for the batteries, maybe $4 and maybe less on AliExpress. If you go to Amazon, which will actually get you things in a reasonable amount of time and they won't be the wrong items, probably closer to 20 or 25 bucks, but pretty cheap.
And software licensing or software costs?
I didn't use anything that wasn't open source. Yep, all open source.
And then how long, when did you start the project and how long did you?
Started the project, Chip, 2-3 years ago? Long time. I think some of the guts of this used to be Chip's, and they were like sitting in a box in his basement somewhere. I was like, I'll make that work. We'll figure it out. So a long time ago, this presentation took a lot more time than actually getting things interconnected. Just figuring out what I was going to talk about and giving an example that was easy to do. The Android stuff was much harder than the Arduino stuff. If I just wanted an Arduino remote and an Arduino tank, I don't know, somewhere between 2 and 5 hours, depending on how many gotchas you happen across. Wasn't too bad, and it's fun. I mean, this is like hobbyist fun toys for kids and grandkids, as opposed to got to make it work right or someone breaks in my house. There's other like Bluetooth low energy applications that are much more mission critical. Medical devices, home security, things like that. But for this, you can take whatever shortcuts you want because it's just a toy tank. Anything I missed? Okay. There are surveys on your tables. I would love to know what I can do better. I enjoy giving this talk, but I know that it's not always everyone's cup of tea. If there's something that I can do to improve this, or if there's something you want to hear about, absolutely fill those out. I'd love to hear back from you.
There is a web Bluetooth API.
Is there? That is so cool.
Probably only Chrome.
That's the next talk. Come back next month. As opposed to running it as an Android app, you can run it as a website, and there's some interface for your JavaScript to like link into the Bluetooth server or client or something on your computer, and you can expose Bluetooth services that way. I didn't know that was a thing. That's really cool. Okay. Well, thank you so much for coming. I appreciated all of your time, and I'm sorry if I'm a little bit late.
It's all good. So just real quick, wait, is mine? Yeah, you can hear me. Next month, the 24th, fourth Wednesday, we have Jaideep Gajrawala from Revology. He's going to be talking about some local development experience stuff. Not sure exactly what it is, but something about setting up local development environments. So that should be interesting. Feel free to stick around and talk if you want. Otherwise, on your way out, if you would like a pizza, feel free to take one. We've got extra. So yeah, thanks everyone for coming. Thanks again, Andreas.
Let me